Hi, so you might recall earlier your teacher hopefully described to you how the advanced mathematics course is what's called a calculus-based course. So there's a certain type of mathematics we'll learn in the following topic, which is called calculus, which is to do with how things change and how we can use functions to analyze that. And so what we're going to do today is quite important for when we get to that later, particularly questions 5 and 6 down the bottom. So we're going to combine functions in some different ways using some our basic operations and then also combine them together, which is called a composite function. So here we've got two functions. One's called f of x, which I'm going to write in blue. And for clarity, I'm going to write this function called g of x in orange. And I'm going to use blue and orange for these throughout, so hopefully it can be visually quite clear what's happening. Okay, so question 1 says we're going to do f of x, and then we're going to add g of x. So f of x is this function, x squared, and if we add g of x is the function 2x plus 4. Well, there we go, they're added. There's nothing really more we can do to simplify x squared, 2x and 4. None of them are like terms. So we're done. Okay, question 2 is to do f of x minus g of x. So our function called f is x squared, and then we're going to subtract. Now if we're going to subtract 2x plus 4 g of x, we're going to have to subtract the whole thing. So there is one simplification we can make this time, which is by distributing the negative through the brackets. So we've got x squared minus times 2x is negative 2x, and a minus times a positive is negative 4. And again, there's no like terms, so nothing to simplify there. Alright, f of x, g of x. Now, here, just like if I wrote fg, what's in between them? Times, right? Now, this is quite important that you distinguish how question 3 and how question 5 are written, because you can see they've both got f, they've both got g, and they've both got two sets of brackets, but they mean two very different things. So this here, with them next to each other, f of x and then g of x, means, with them written like that next to each other, means the function f times the function g. So f of x is x squared, and we're going to times by g of x, and again, when we write it in, since there's multiple terms, we'll write them all in brackets. And so now we've got brackets to distribute again, so x squared times 2 is 2x cubed, and x squared times 4 is 4x squared. So that's f of x, g of x, which means f of x times g of x. F of x on g of x, right, is divide. We've got x squared on 2x plus 4, and it doesn't look like there's anything we can simplify there, so f of x divided by g of x is x squared on 2x plus 4. Okay, so here's the really important bit, is question 5 and 6 are what's called composite functions. So you see it says f of, and then what's inside? G of x. So hopefully writing with the colours makes that a bit clearer. So this says find f of whatever g of x is. So g of x we're going to replace with, we're going to find f of g of x is 2x plus 4. Now just as a little aside, you might recall you're assigned in exercise 302 of Maths in Focus. One of the questions was question 10. Here's a function is 2x minus 9, and it said find f of, I'll use another colour, f of x plus h. Now finding a function of inputting x plus h is actually quite important for calculus as well when we get to it. Okay, so this says, the function says 2 times the input value minus 9, and everywhere you see x, you're going to replace it in here with x plus h. And then you can expand those brackets and simplify that. So, similarly here, the function f, if I zoom out so this can all fit, the function f says the input squared. So whatever we input, we're going to square it, which is what the blue is saying to do. That's the function f. And what are we inputting? We're inputting 2x plus 4. Right, and so now we've got an algebraic expression, 2x plus 4 all squared, which you could write as 2x plus 4 times 2x plus 4 and use FOIL and collect like terms, or if you recognize it as a perfect square, it's the first one squared plus 4 times 2x is 8x. Them times together and doubled plus the last one squared. Right, so again, just be careful here with question 3 and 5, right? Notice very similar amounts of symbols, almost the same except there's one less x in how they're written, but because 3 is written next to each other, so that means they're timesing, multiplying, but with 5, one's written inside the other one. So it's a function of another function. Right, so this here, language we might refer to this is a function of another function, function of a function, or we'll call this a composite function, right? The other 4 we combined above, there's no real, you can just use normal language like the sum of the functions, the difference, the product, the quotient, right? But this is something new, and this is called a composite function. Now, another way we could have written f of, I guess I'll keep the colors, g of x is, there's another symbol for this, which is f, and this little kind of degree symbol or circle that's written like in the middle means a composite function as well. So f of g of x, right? So I think of the little symbol like an O, like of, f of g, means the exact same thing. So it's just more notation, different ways to write the same thing. So if you see f of g of x means f of g of x means f of g of x inside. Right, so question 6, notice, uses that new symbol, but because the order is different, the order is important, right? So we've got g of f of x means the same thing as g of f of x. Now, what are we going to input into g? Well, we're going to input into g f of x, which is our function x squared. And then, what does the function g of x say to do? Well, it says 2x plus 4, so it says 2 times whatever you input and plus 4 to it. And what are we inputting? We're inputting x squared. So then the only simplification we need to make is that we don't need to write the brackets here. 2x squared plus 4. Right? So because there's two functions, if we're composing them, there's 2 ways we can do that. right? And the order here is important, right? If you look at what I'm just highlighting now, this one in green here, f of x squared, 4x squared plus 16x plus 16, and g of x, right, 2x squared plus 4, they're clearly not the same expression. So the order is important when you're doing composite functions. So I would strongly suggest using multiple colors to be able to visualize this similar to how I've done. And yeah, and that's it for this video. Bye.